this recording will cover us rewriting this term and this term as one term so that then we can do the numerator denominator, and then I'll put my phone under the camera where we talk about that numerator less than, equal to, greater than, and then I'll show you guys that Bobo. Remember I kind of showed you yesterday? So if any of you guys end up getting tutoring from someone, I'll show you that Bobo, Bo2, DC. Okay, it actually applies to this one. Okay, so look, remember, if you're going to do the numerator, denominator, and compare your degrees, you need to get it into one term, okay, one fraction. All right, you got two terms here. So this is my denominator. That's going to be my common denominator because this is really over 1. So I'm going to multiply x minus 3 to numerator, denominator, right, to the ratio 2 over 1. And so I get 2 times x is 2x, and 2 times negative 3 is negative 6. And so when you combine your numerators, 1 plus 2x minus 6, right? And then the x minus 3 only gets written once because that's my common denominator. Then I end up with 2x minus 5 over x minus 3. So this is the rewrite, right, to the 2 term. Okay. Now, once you have it as one fraction, now you can talk about the numerator, denominator, right? So this is a numerator, this is a denominator. Okay, what's the degree? 1, right? Because it's really a little 1 here. Okay, what's my leading coefficient? No. That's your constant. What's the leader coefficient? 2. It's in the front. It's the leader, right? So look, 2x to the 1. Leading coefficient, degree. Okay, so now look at the denominator. What's my degree? Huh? 1, right. And then, where am I? Oh, and then what's my leading coefficient?
2x.
Yes. This is really 1x1, right? It's all implied. Like, do you want a water bottle? Oh, can I get a number 2 with cheese, whatever, right? You don't say number 1. You don't say, do you want 1 water bottle? It's implied. Same with mathematics. The ones are implied. You're not going to see it. Okay. Okay, so we're going to do horizontal asymptote first, and then we'll get to vertical asymptote. Okay, so horizontal asymptote. Look, if you're going to struggle with this, it's going to be horizontal. Vertical, you guys are better at. Okay, so, and the reason why you know is because, let me get to my pictures, hold on. Okay, this is how I'm used to learning it, and that's why as I go through them, I'll like compare like the numerators equal to the denominator, so then it's a fraction of the leading coefficients. Okay, so here, if the numerator is equal to the denominator in degree, then the asymptote is equal to the leading coefficients as a fraction. Okay, that's how I'm used to it, but for those of you that like, I don't know, your friend got caught by Bo2 eats DC. Okay, Bobo would be big on bottom, y is 0. So if the degree is bigger on the bottom, your asymptote is 0, right? So it's Bob with a 0. BOTU is big on top, then it's an undefined asymptote. Each DC is, if the exponents are the same, then you divide the coefficients. I've never heard this, ever. All my years learning, going through high school and all that. Okay, so what I'm used to is just this. How are the numerator, denominator degrees? How do they compare? Okay, so we're in the middle. So because they're both 1, 1, right? See here, degree is 1, degree is 1. So if I move this to the side, I have 2x to the 1, 1x to the 1. My n is equal to my d, right? Oh, did it freeze? Oh my god, you guys, wait. Oh no, it didn't. Oh, okay. Okay, so the numerator is equal to the denominator in the degree. So if they're equal, then your asymptote is a fraction of your leading coefficient. So what's 2 divided by 1? 2. And so my horizontal asymptote is y equal 2. Okay, and we'll go through vertical asymptote. All right, vertical asymptote. If I look, oh wait, is it on camera? Yeah. If I look here, my denominator is x minus 3. Your vertical asymptote is always the restriction where the denominator cannot equal 0. Your vertical asymptote will always be the denominator, never the numerator, denominator. So if I set this equal to 0, what value makes the denominator 0? 3. And so your vertical asymptote is positive 3. All right, so let's plot these. Okay, so we have x is equal to 3. There's my vertical asymptote. And then my horizontal asymptote is y equal to okay, and now you just pick values to the right and to the left of your pink vertical asymptote. So if I'm at 3, I'm going to pick 4 and 5, and then over here I'll pick 2 and 1, or 1 and 2, right? And then you just grab a calculator and you substitute, and that's, let's try and figure it out. Move the camera closer. And then let's grab that. Okay, so what is it? Fraction 1. Okay, we'll put in 4 first. Minus 3 plus 2. And I get 3, and then I plug in 5, and I get 2.5. So 4, 3, 1, 2, 3, 2.5. So hold on. All right, let me just. Okay, and then substitute, oh, I didn't mean to delete it. 2 minus 3 plus 2, 1, and 1.5. And let me just turn it a little bit. Okay, and so, here, let me elevate it. Here is your graph, yeah? On these little graphs, I increment it ones, right? I mean, I don't write anything, but I just have ones here. But if you ever want to go every 2 and go 1, 2, 3, go by halves, it's up to you. You guys have this. If you guys ever, on your test, you want graph paper, I'll give you graph paper if this is too, squished for you. Okay. Okay, we'll divide polynomials, but let's get this going. Can I stop the video? Yeah? Okay. Stop. Stop or stop?